Welcome everybody. Today we are going to go over 8.1, simplifying and multiplying rational expressions. So a rational expression is a fraction of two polynomial expressions. So you'll notice this page is full of fractions. So simplifying irrational expressions, we're going to factor everything that can be factored. We're going to simplify monomials, so things that have one term on the top and bottom, using our exponent rules, and then divide the binomials. So a few different things to remember. When you are dividing two things with exponents, so maybe something like this, we subtract the exponents. So it'd be like 3 minus 2, so the 2 gets subtracted, the 3 turns into a 1, so we'd be left with just an x to the first power or an x. If the x had been on the bottom, say it had been like x to the third over x to the fifth, when we subtract them, the smaller one goes away, and wherever the bigger one, that's where the x stays. So this would turn into 1 over x squared. And then we've been doing it a lot, but when you multiply things with exponents, so if they have the same base, you would add the exponents when you multiply. So this would turn into x to the fifth. When you divide binomials, so say I have something like x over x, anything divided by itself equals 1. So if I have like x plus 2 over x plus 2, that is something divided by itself, so it also equals 1. So that's kind of what it means by divide the binomials, is if you have two terms that match in a group, so like these are groups together, they would divide to equal 1. So a lot of times I'm going to call that canceling them out. They're not really canceling, they're turning into a 1, which is usually invisible. So let's check this out. So looking at number 1, we have two monomials, so we're just going to simplify each of the parts. So I usually break this up. So if you want to, you could separate them. So we could separate this into like the numbers times the x's times the y's. This y has an invisible 1 for the exponent. You don't have to do it that way, but if that helps you kind of see the different parts. So the numbers can both be divided by 6 to simplify. So this would turn into a 2, this would turn into a 3. The x's would subtract, so the 2 would go away. 5 minus 2 is a 3. And the y's would subtract. The 1 would go away. 3 minus 1 is 2. And then I can put it all together. So on the top of the fraction, I'm left with a 2, and I'm left with a y squared. The bottom of the fraction, we're left with a 3, and we're left with an x cubed. So frequently I don't split it up like that, but if that helps you see it, you can always split them up into parts and then put it back together. On the flip side, on number 2, they are split into parts, but they're not organized very well. So I would recommend multiplying them all together. So you would do like the top, you would do 3 times 8 times 2, which equals 48. And the x's, we would add together their exponents. And then on the bottom, we would multiply the numbers. And then this x has an invisible 1, so if we add those, they turn into x to the fifth. Then if you want to split up the numbers and the x's, you can, now that they're combined, or we can just simplify. So these numbers can both be divided by 12. So this turns into a 4, and this turns into a 5. And then the x's, we subtract the smaller from the larger. So we're left with a 4 on the top and an x cubed. And on the bottom, all we have left is a 5. So if you want to, I would try out number 3 and then watch the video. So on number 3, there's an invisible 1 right here. So I would multiply negative 1 times 3 times negative 6, and that would turn into an 18. And then this x has an invisible 1, so the x's, when I add them, they turn into x to the fifth. On the bottom, we've got 4 times 2 is 8. We've got that invisible 1 on the x, so that turns into x cubed. Then I can try to simplify, so the numbers, I look at those and I say I could divide both of those numbers by 2. So this turns into a 9, this turns into a 4. The x's, we would subtract them, so 5 minus 3 equals 2. And the bigger one's on top, so it stays on the top. So I'm left with a 9 on the top and an x squared and a 4 on the bottom. All right, let's check out number 4. So number 4, they've actually put it in factored form. So we have a few different binomials, and in the front, we've got some monomials hanging out. So things to look at. Each of these, because they're touching, are being multiplied. So if you want to, you could break it up, kind of like we did problem number 1, and you could split them into parts. Or we could look at the things on the outside. So looking at just this part, because they're both on the outside of fractions, we could see how could I simplify that fraction on its own. So looking at that, the 4 and the 18 are both divisible by 2. So this turns into a 2, this turns into a 9. My x's, I've got the invisible 1, so 4 minus 1 turns into a 3. Looking at the binomials, so those parentheses, I see a 2x minus 1 and a 2x minus 1. We talked about earlier about how if you have something divided by itself, it turns into a 1. So both of these can cancel out because they would turn into a 1, which is then going to be invisible. So what we're left with on the top, we've got that 2 still. And I still have an x plus 4. Oh, I forgot that x. We've got that x cubed as well. And then on the bottom, we have the 9. The x went away, and we still have an x plus 2. And from there, I don't see anything else I could simplify, and you do not need to distribute, so I would leave it in factored form. So that one was nice. We could see the factors, so when we had factors in common, they would simplify to a 1 and cancel. Number 5, I don't see any factors that cancel yet. So I think a lot of people have a misconception where they would try to cross off the x and the x. However, because there's a plus sign separating them and a minus sign, you cannot do that. So these ones you want to factor first, because the factors would divide to equal 1. So on the top, I can't factor that, but on the bottom I see a trinomial. So my a times c would give me negative 10, and the b is negative 3. So two numbers that multiply to negative 10 and add to negative 3. That works. So my new fraction, the x plus 2, stayed the same. And on the bottom, we can use our shortcut and do x minus 5 and an x plus 2. Nice. So we have an x plus 2 on the top and an x plus 2 on the bottom. So this x plus 2, even though we don't see parentheses, they're a group. So this x plus 2 and this x plus 2, they would divide to equal a 1. This time the 1 doesn't disappear because there's nothing left on the top. So when nothing is left on the top, you want to put the 1 there, because that x minus 5 has to stay on the denominator. It can't just switch to being on the numerator. All right, let's look at number 6. Number 6, ooh, so these are two different parts being multiplied. So if you notice at the beginning, it said to factor everything first before we multiply. So looking for factors here, I see a GCF right here. So a GCF we could take out of that group would be a 2. So if we take out a 2, we're left with 3x plus 2. So that replaced this. Then something we haven't talked about yet is a cross simplifying. So here we kind of like, if you see something on the top and on the bottom that can simplify, you can do it. So even when they're split up like this, we can simplify the top and the bottom. So like I see a 2 here and a 2 here, so those can simplify to 1. I see a 3x plus 2 here and a 3x plus 2 here. So because those groups match, they would simplify to equal a 1. So even though they were in different fractions, because the one was on the top and one was on the bottom, when I multiply, they would eventually combine together, so I can simplify them. And then with the x's, I see an x to the 3 and an x to the 5. So 5 minus 3 equals 2. And I think that's all we can do. So on the top, we're left with a 3 and an x squared. And everything else canceled, so that is all we are left with. So simplifying diagonally is also a tactic you can take. All right, let's flip the page. So 7, again, we have two fractions with a multiplying sign in the middle. So before I stick them together, I want to try to factor. So the left fraction, I don't see any factoring, but the right fraction, I see a trinomial on the top, so I'm going to try to do the x. So multiplying to negative 6, adding to 5 would be 6 and negative 1. So I know the top of this one's turning into an x plus 6 and an x minus 1 has now replaced this. On the bottom here, I see a GCF. So those both have an x cubed in common. So I can take out the x cubed and we're left with x squared minus 36. Ooh, I see two terms with a minus sign. So that minus sign tells me that I can do difference of squares. So I can take the square root of both of those. So that'll turn into an x plus 6 and an x minus 6. Make sure you have both. and that x cubed is still in the front. So let's rewrite all this to make it look nice again. So the left fraction stayed the same, and the right fraction is turned into x plus 6 and x minus 1. And on the bottom, we've got x cubed and x plus 6 and an x minus 6. So now we want to look at the tops and the bottoms of this fraction and see if anything would simplify. So I see an x plus 6 and an x plus 6 on the top and bottom, so those equal 1. I see an x to the 1 here, so I can subtract that from this x to the third and make it a 2. Ooh, so I bet something that some people want to do is this x minus 6 and x minus 6. Those actually cannot cancel because they're on the same level as each other. So those actually are going to be put back together. So on the top, we're left with an x minus 1. On the bottom, I see two x minus 6s. So because there's two x minus 6s, we can call this x minus 6 squared. And then I still have that x squared, so that x squared will go in the front. So that is all we can simplify there. The reason I can't simplify the x with the x squared is because the x is attached to this x minus 1. So it's a group with the x minus 1, so it could only cancel out with another x minus 1. So that would be our final answer. All right, looking at number 8. I see a few different factoring things we can do. So the bottoms all look great. The tops, I see a trinomial, so I like to handle those first. So I've got a negative 54 and a negative 3. So 9 times 6 is 54, and negative 9 and 6 is negative 3. So I know this one's going to turn into an x minus 9, an x plus 6. The top of the other one, I see a GCF. So GCF there would be a 3, so we could take out the 3, and we're left with x squared minus 9. Ooh, I see two terms with a minus sign again, and those are perfect squares. So we can take the square root and the square root. So we're left with x plus 3, x minus 3, and that GCF of 3 is still in the front. So let's rewrite it so we know what we're working with. So we've got 3x plus 3, x minus 3, all over x plus 3, times x minus 9, x plus 6, all over 6x minus 9. All right, so we're comparing the tops and the bottoms to see what I could simplify. So x plus 3 can go. X minus 9 can go. And then I have this 3 and 6 hanging out on the outside. So we know that we can simplify 3 and 6 because they're both divisible by 3. So 3 divided by 3 is a 1, which could be invisible. And 6 divided by 3 is a 2. So what we're left with on the top is we've got that 1, and we've got an x minus 3 and an x plus 6. If you want to write the invisible 1 in the front, you can, but you don't have to. And then on the bottom, all we have left is that 2. So things outside the parentheses we can simplify, and then the parentheses themselves, we try to find groups that match to simplify on the top and on the bottom. All right, let's do one more. Ooh, this one's got a few parts. Okay, so I see a few trinomials. So I'm going to start with the top left. So we've got a negative 6 and that invisible 1. So 3 and negative 2 would work for that. So I've got an x plus 3 and x minus 2. The one right below it, we've got a negative 3 and a 2. So that would be 3 and a negative 1. So we've got x plus 3, x minus 1. On the right side, it looks like we've got a GCF right here. So we can take out that 3, and we're left with x plus 1. The bottom, I don't like having that 4 in the front, so I would immediately try for a GCF. So I believe we've got a 4 that could come out. So if we take out a 4, we're left with x squared minus 2x minus 3. So we could do another x for that. We've got a lot of 3's and 2's in this problem. So negative 3 and 1 should work. So we've got 4x minus 3, x plus 1. So I'm going to rewrite all that just to make it look nicer. So we've got x plus 3 over x minus 2. over x plus 3, x minus 1. We've got a 3 and an x plus 1, and a 4, x minus 3, x plus 1. All right, now that everything's factored, we look at the top and at the bottom and say, what could we simplify? So x plus 3 goes. X plus 1 goes. The 3 and the 4 don't have anything we can divide them both by. So I think we're done. So the numbers I like to put in the front, so the 3 I would put first, and then the x minus 2. And then I'd put that 4 in the front, and then the parentheses. So an x minus 1 and an x minus 3. And we are done. So nice thing about these is you want to keep them in factored form. So once you create the factors, you want to keep them that way. All right, I hope that was helpful, and good luck on the practice.